analytics. I just put in the chat. A link of if anybody, you don't have to scribble and try to take snapshots. My philosophy to science is that if it's not fully available and openly accessible online, it just doesn't exist. So I would never show anything that you cannot reproduce in your own shop, in your office, or in your own classrooms. So these are the links that I essentially want to go over and kind of show you very quickly, some of the content that we have in the data science book. So this is the website. Now, most of us that come from academic institutions, when you go to the Springer link, because most university libraries actually subscribe to Springer Nature subscriptions, they are going to have, once you log in through your library website, you will be able to download the book completely for free. Again, from your website, as you can see here. I just downloaded the book, so there is no mystery. My students use it exactly the way I'm showing you here, right? So very briefly, just to show you, this is the second edition. It was redesigned quite a bit. The first edition came about 6 years ago, and it was, a first foray into the data science and machine learning. The second edition transformed the 23 chapters that we used to have into 14 now more succinctly ordered chapters. It starts with a motivation. It justifies why do we use R instead of Python, SAS, MATLAB, Mathematica, you name it, right? There is so many different platforms you can use. So we justify the use of R in our case. Then it goes through, what many books do very well, the basic exploratory data analytics, right? Visualization. Then it goes into linear algebra, matrix computing, and regression modeling. I know this, you can teach actually a year-long course just on that, right? So, but, it shows the basics. For me, it's very important to make sure that students that are not particularly STEM prepared can understand the notion of what a matrix is, what a scalar is, what a vector is, what a matrix is, what a tensor is, because these are objects that are very important in anything that has to do with data science. And then the next chapter deals with supervised classification methods. Then the next one goes into black box machine learning methods, a whole bunch of them. Again, I'll show you in a second more details about each of these. And then the next one is qualitative methods, text mining, natural language processing, the a priori association rules learning. And then you go into the model-free inference, basically, where you have unsupervised clustering, right? You essentially have a data set that doesn't have a clearly delineated outcome. And what you're looking for is you're looking for identifying patterns, traits, groups, and so forth into the data set that might have interpretations that have, in our case, clinical relevance, social relevance, economic outcome, environmental, and so forth. So, and then once you kind of build the notion of what are the basic statistical model-based and model-free machine learning methods, we kind of dive into, well, how do you actually assess the performance of these things? How do you quantify, performance? So there's a whole chapter on that. And then there is a very interesting specialized machine learning topics that discusses anything from SQL queries to Google Big Queries to what's very dear to my heart, the integration of Python, R, C, C++, Fortran, JavaScript. The R Markdown electronic notebook in our studio allow you to literally integrate, essentially develop a protocol, end-to-end protocol that includes stuff that you didn't write. Somebody else write the C code, Fortran code, it doesn't really matter. It all can be built in the same electronic Markdown notebook. So this is incredible power that our studio and RMD, the R Markdown, allow you to use. And then variable importance and feature selection, obviously, the classical recursive feature elimination, to the more modern ones, including, random forest feature selection, including regularized linear modeling, including something called a knockoff filtering, and so forth. That's an interesting chapter. And then we go into big longitudinal data, right? What happens if the data varies with time? And Julia mentioned, our group has developed something called complex time that kind of extends that notion of the longitudinal event order into higher dimensions. And then a chapter on function optimization, which again, it may be a little bit mathematical, but the examples that we show inside are really, really interesting. And we actually work out a few examples completely by hand, no calculus. We do the examples by hand, then we do it through calculus techniques using gradients and so forth. And then we use algorithmic capabilities and functions to solve it computationally. And we show that all three things, right? The completely by hand solution, the mathematical analytical solution, and the computational numeric solutions, they kind of yield the same result. So, and this is important because in the last chapter, and this is one of the largest one, we talk about deep learning and most importantly, transfer learning, right? Everybody's familiar now in the news, this notion of foundational artificial intelligence, right? Generative artificial intelligence. This is really, really powerful strategies to do, statistical learning in general, but inference, prediction, forecasting, and so forth. And it's all predicated on proper optimization ways, proper optimization strategies. So, again, the website, which is listed over here, includes all the content for free. So I'm just going to get a completely random, right? So there is assignments, there is class notes, there is R code. For each of these sections, the complete R Markdown notebook is listed over here, as you can see, right? So I'll just, open the random section. And you can see now, because these are some of these chapters, electronic chapters that we have are literally hundreds of megabytes long because they actually have dynamic content. We actually have three-dimensional objects you can manipulate in the browser. It's just mind-boggling what you can do nowadays with R Markdown. So it's going to take a little bit of time, but again, the navigation on the top allows you to go from the SOCR resources to the data science and predictive analytics to the topics and so forth. And, I don't know, just let's go to T-distributed stochastic neighbor embedding, right? So we present the mathematical foundations of what is this all about. We present an example in this case of how is handwritten recognition happening. All the data are available on the website. You don't have to do anything special. You can hide the code if you want. You can show the code. You download the data. Then you go through the process of, increasing memory and all kinds of other things. You demonstrate a few of these 32 by 32 images that you're going to be recognizing as digits, right? You plot. So here's your dynamical content that I mentioned, right? Many of the graphs and the plots, this is just two-dimensional one, but we have three-dimensional as well. So the first few examples. And then you actually go in and run the t-SNE, specifying you want to project this 784-dimensional data into 2 dimensions. It goes through the optimization process. And then here is, again, a very interesting 2-dimensional projection of 1,000 of these handwritten digits, right? And you can see the nice clustering, right? There you have the 7-digit, the images that represent 7 are over here and so forth. And again, this is all kind of dynamic as well. And then you do performance, and here is the 3D. So here is one of those dynamic 3-dimensional objects that you can actually demonstrate directly in your classroom to indicate that indeed t-SNE works for these kinds of things, right? And this is just one example. You can do more colorful things, forget about the numbers, just color code them. You can navigate. And then you dive into a second method and so forth. So I'm not going to walk you through. This is not a course curriculum. So there is prerequisites. Obviously a little bit of STEM science would be useful. We have a MOOC version, right, for students mostly that are outside of our university, right, that still want to get access to this. We have a completely free and open with videos and everything else that kind of goes with it. We have the expected outcomes, desired competencies that they want to build at the end, right, and so forth. And then here are the modules, again, the modules that correspond with, there is book reviews and so forth that you can see. The book is available in many different libraries. And now I'm a huge fan of this specific visualization here, which allows me to now say, suppose I'm just interested in getting to the deep learning. What's the fastest way for me to get to deep learning, right? So deep learning is right up here, okay? And just double clicking this block opens the section for me, right? So this is a dynamic graph that kind of shows you how you can, and unfortunately, because I opened this very, very large file, now see my browser is stuck because this is one of those 200 megabyte web pages that's generated, but eventually it would load. And you can see now that to get to deep learning, I got to go through the black box methods. I have to go through some of these linear models. Again, all of these are hot links. I can just click here and go to the website. So from here, you can essentially say many instructors they don't need the whole thing. This is for a 2-semester graduate level course. If you're just interested in longitudinal data, you just take the track here that's in this Sankey diagram, right? And then finally, we have a whole bunch of cases, hundreds of case studies that come from health and biomedicine that allow you to, enormous data sets, some of them which are very large, right? These are not academic exercises. These are real data sets that are very difficult. And many a times you're going to see that standard classical statistical methods just don't work with these things. Parametric assumptions are violated. The data is highly associated. The data is not IID in a way. So there is a lot of this is real data sets that you can use for free, right? So you see, I'm not logged in here. This is accessible to everybody. So I'll just stop here and see if there are any questions or specific things before we go to Ali and for his very interesting diffusion modeling presentation.